Alrighty, so you'll recall that each equation has a unique line represented on the graph. So when we're graphing lines, we're going to use this y equals mx plus b. That's slope-intercept form. Okay, so we will need to memorize that. The m, hopefully we know and remember that the m stands for slope, and that's always going to be a fraction. So even when your slope is like 2, we would say it's 2 over 1. Rise 2, run 1. And then the b is the y-intercept. So that's really where it's crossing the y-axis. Okay, so that vertical axis, where does it cross the y-axis? So there's two different things we could do. We could create an equation, if we are given an equation, we can create a t-chart by substituting in values for x to solve for the y values. So you're going to pick like really easy x values, like -1, 0, and 1, or -2, 0, and 2. Then you're going to plot the ordered pairs on the grid. And then you're going to connect the points to form a straight line. So let's try that right now. So our first equation in y equals mx plus b form is y equals half x. So I always rewrite the equation on my table. So like I said, you're going to pick easy x values. So I'm going to pick -2, 0, and 2. We wouldn't want to pick like -10 because that's not going to fit on our grid. Then we're going to substitute in the x values where we see the x in the equation. So I'm going to take half, and half and x are multiplying, right? Because they're next to each other. So I'm going to substitute in that -2. Then I'm going to do the same thing with 0. Half times and plug in 0. And I'm going to do the same thing with 2. Half times 2. So then once I compute each of those, or once I have each of those, I'm going to actually solve for y. So you can do in your calculator 1 divided by 2, which is 0.5, times your -2. And when you do that, you should get -1. So if I put that all together, my x value was -2, and my y value was -1. So now I'm going to try it with 0. Half times 0 is 0, so that would just be 0, 0. And then half times 2 is 1. So I would say that would be 2, 1. Okay, now it's time to graph. So we've got -2, -1, 0, 0 goes right through the origin, and 2, 1. Then I connect with the straight line, always draw the arrows, and you are done. All right, let's take a look at the next one. Graph the line y equals 3x minus 2. They don't give us a table, so we can make our own. Okay, and I'm going to use -1, 0, and 1 for this table. Make it even a little bit easier for myself. Okay, so same thing. I'm going to take this equation, 3x minus 2, and substitute in the x values. So 3 times -1 minus 2. 3 times 0 minus 2. And 3 times 1 minus 2. So go ahead and use your calculator to compute those. So you're going to do 3 times -1, which is -3. -3 minus 2 is -5. So those coordinates would be -1, -5. 3 times 0 would be 0. 0 minus 2 is -2. So we've got 0, -2. 3 times 1 is 3. 3 minus 2 is 1. 1, 1. Now we'll go ahead and graph. -1, -5, 0, -2, and 1, 1. Connect them, and we've got a straight line. Okay, go ahead and flip to the next page. If you need more time, you can pause and you can write all that down. I know it's a lot of information, but when you're ready, go ahead and go to the next page. So sometimes we're given the slope and an ordered pair. So the first thing we're going to have to do is plot the given ordered pair. That's really important on the graph, if they give us an ordered pair. Second step, we're going to follow the slope using rise over run to plot the next point. And finally, we're going to connect the 2 points with a straight line. So here's A. It says graph the line with the slope of 2/3 that goes through the origin. Well, I know the origin is 0, 0. So I'm going to start at 0, 0. And then my rise is what? And my run is what? Well, I follow the slope. That's where I find the rise over run. So my rise is 2, and my run is 3. So starting at the point they gave us, starting at the origin, I'm going to rise 2 and run 3. So if you couldn't follow that, that was follow 1, 2, rise, run 1, 2, 3. Okay? And I can connect my 2 points. Next one, we're going to graph the line with the slope of 1. Now, if it says a slope of 1, that really means a rise of 1 and a run of 1. And this goes through the point 0, -3. So 0, -3 can be tricky. It's not going to move along the x-axis, but it will move down 3. So there's my 0, -3. And from this point, we're going to rise 1, run 1. Rise 1, run 1. And that would be my line. Okay? And the last one that we'll do is if we're given an equation. So it says given an equation, determine the slope and the y-intercept from the equation. So we'll have to determine, well, in y equals mx plus b, what's in the spot of the m, that's the slope. What's in the spot of the b, that's the y-intercept. The first thing we want to do is plot the y-intercept on the y-axis. Then from the intercept, we're going to follow rise over run and plot the next point. Finally, we'll connect the 2 points to form a line. So in this problem, what's in the spot of the m? Well, there's nothing written in front of the x. So I look at my x, well, how many x's do I have? I have 1 x. So my slope is 1 over 1. And then in the b spot, we see a 2, but make sure the entire thing has to be written. So your y-intercept would be -2. So I'm going to plot -2 on the y-intercept. That's what step 2 tells me. Plot the y-intercept on the y-axis. There's my y-axis, plotting -2 on the y-intercept. Step 3. Follow the y-intercept, or from the y-intercept, excuse me, follow the slope using rise over run. So I'm going to rise 1, run 1, draw my dot. Rise 1, run 1, draw my dot. And from there, I have my line. Okay, let's try to figure out what our m and our b are for this equation. So we've got b right above, right underneath would be 1, and then m right underneath would be half. So again, I'm going to start at B, which is 1, and I'm going to rise 1, run 2. Rise 1, run 2. And from there, I connect and make a straight line. Alrighty. We just have one more problem left to do. It's an application problem. Or 2 more, excuse me. We'll just do 1. And then I'll have you try the last one on your own. So it says, Josh buys candy at a store that charges $1.50 per candy bar. Create a table that could represent Josh's cost per candy bar. Graph the points in the graph and create a rule that represents the relationship. So it's saying for every candy bar that I buy, so X is the amount of candy bars, and Y is the cost, it's $1.50 per candy bar. So $1.50 times X. So say I want 1 candy bar, 2, 3, or 4 candy bars. I'm going to take the 1 candy bar and multiply it by how much it costs, $1.50. So 1 times $1.50 would be $1.50. If I bought 2 candy bars, that would be $1.50 times 2. That would be $3. If I bought 3 candy bars, $1.50 times 3, that would be $4.50. If I bought 4 candy bars, $1.50 times 4, that would be 6. Okay, so then you would want to go and graph it on your own. Okay, so I'll have you do graph it on your own, and I'll start with the next one. A new ice cream shop only charges $3 for a cup of ice cream. Then they charge you $1 for each topping. Make a table of values graph and find the equation that represents how much it will cost with each additional topping. So we've got to figure out $3 for a cup and $1 for each topping. So which number goes where? Well, I know it's $3 a one time just for the ice cream. So $3 is the Y-intercept because I'm only paying it one time because I'm buying one thing of ice cream. But then the word each is really important. We know it's $1 for each topping. So $1 for each topping, one times the number of toppings, because the number of toppings is basically your X. So say I had 1 topping, 2, 3, and 4 toppings. Okay, so to find the cost, I'm going to take the $1 times the cost for one topping plus 3. So 1 times 1 is 1, 1 plus 3 is 4. 1 times 2 plus 3, 1 times 3 plus 3, and 1 times 4 plus 3. Okay, so 1 times 2 is 2, 2 plus 3 is 5. 1 times 3 is 3, 3 plus 3 is 6, and 1 times 4 is 4, 4 plus 3 is 7. So go ahead and graph those on your own, and then you can stop the video, and I will check in with you.